Hello everyone, Namaste. In this video, we will deal with 11 things to remember while carrying out data analysis. It's me, Rohan Bhajankar, and we will deal with these 11 most important things to remember while carrying out the data analysis. And you can follow me in my blog rohanbhajankar.com.nb, and you can also follow me in Facebook, facebook.com/rohanb.nb. So now let's start. The first thing to remember is we must be able to the answer these two questions. Question number one and question number two. They are the variables which I have taken lies in with scale of measurement. You must know, or uh, one must know the variable which they have taken lies in which scale of measurement. Such as if I take the variable gender, then gender is an categorical variable, so it lies in the nominal scale. And the second question is, which statistical test shall I perform in defined scale of measurement? That is, if I have taken the variable gender, then I have known that the gender lies in nominal scale. Then, following this, I must know which statistical test shall I use in the nominal scale. These two questions are the basic question that the researcher must know while carrying out the data analysis. So now moving forward, the second thing to remember is there are four scales of measurement. First is nominal, second is ordinal, third is interval, and the fourth is ratio. What is nominal then? Nominal is a categorical variable with no meaning of numbers, such as gender. If I code gender as 1 for male and 2 for female, then the numbers have no meaning. Means that I cannot add the 1 and 2 and call it as 3 because they are simply the codes. And following the gender, the other variable is religion. Religion can also be categorized into different forms such as Hinduism, Buddhism, Islam, Christianity, and we can code them all. If I call Hindu as 1, Islam as 2, Buddhist as 3, and Christian as 4, then they are simply the codes. I cannot add them up. Following the nominal scale of measurement, there is ordinal. Ordinal is just like nominal, but there is ranking. Means that I can rank the choices, such as attitude scale, pain scale, and the educational level. These are the ranked variables, and the Likert scale is the best example of the ordinal scale. And the third is interval, numbers with no true zero, such as temperature, time, but GPA has a zero. Zero means there is no marks. But GPA is an interval scale because if one gets 4 GPA and other gets 2, then we cannot say that a person who is getting 4 GPA has has twice marks as of 2 GPA. And for ratio, numbers with true zero, they are distance, height, weight. It also means that there is starting point. If the distance is 0, then we say it that we haven't covered or we haven't started our journey. And a third thing to remember, this is the most important part one must know while carrying out data analysis. It is it is one must know that there are four levels of scale of measurement, and one must know which statistical test should one perform in these scale of measurement. For nominal, I can perform mode. For ordinal, I can perform median and mode. For interval, I can perform median, mean, and mode. And for the case of nature is I have already told in the previous slide. And for the numerical interpretation, it is also in the previous slide. For the measure of dispersion, for nominal there is no measure of dispersion. For ordinal, rank, interquartile range. For interval, range, interquartile range, standard deviation, variance. For testing of hypothesis, there is chi-square test for nominal, there is chi-square test for ordinal, t-test and ANOVA for the interval and the ratio. For the relationship between variables, phi coefficient for nominal, Spearman's rank correlation for ordinal, and for interval and ratio scale there is Pearson correlation. Similarly, the last is the example for nominal is gender and religion, for ordinal is Likert scale, education, attitude scale, pain scale, and for interval it's temperature, GPA, time. For ratio it's distance, height, weight and age. And the fourth thing to remember is tables and graph. In nominal scale and ordinal scale we can create tables, two-way table, three-way table and multiple way tables. And for the nominal scale, in case of graphs we can create bar chart and pie chart. For ordinal we can create bar chart, pie chart and box plot. For interval there is no possibility of tables. For ratio there is no possibility of tables because there will be lot of data points, so the table will be extremely long and it's meaningless. And for graph we can create histogram, box plot, line chart, population pyramid, scatter plot. But for scatter plot both the variables must be numerical, such as income and expenses, demand and price, supply and demand, and so on. They must be numerical in nature. And the fifth thing to remember is relationship between variables. If our variable is of categorical nature, if both variables are of categorical nature, then we will use phi coefficient and rank correlation. If one variable is categorical and other variable is numerical, then we will use t-test and ANOVA. T-test and or ANOVA. And both variables are numerical, then we will use Pearson's correlation. And this is the matrix. This is a relationship between variable matrix. So this matrix will help you out in determining which test to perform to find out the relationship. And the sixth thing is hypothesis testing. If one variable is numerical and other is categorical with only two categories, then we can use t-test or ANOVA, one-way ANOVA. If one variable is numerical and other is categorical with two or more categories, then we must use one-way ANOVA. If both variables are categorical, then we will use chi-square test. And following this, the seventh thing to remember is accept or reject your claim or null hypothesis. If p value or the significance value is less than 0.05 or 5%, then reject the null. We must reject our claim. If p value or significance value is more than 0.05 or 5%, then do not reject the null hypothesis. And the eighth is z score of 2 till 90% equals to z score of 1 till 95%. And this is clearly presented by the figure below. And the figure source is, I have given the image source and you can click on this link, as I have given the slide in the description box. You can also download the slide. And the most important thing to know is z score of 2 till 90% equals to z score of 1 till 95%. The ninth is t-test is appropriate for small samples. However, t-test and z-test give same result for large samples. You can here see at the degrees of freedom 30 in the first figure, and the t value is 2.0423 for t value 2 tail. Similarly, if the degrees of freedom is increased to 50, then the t value will fall to 2.0086. And if the degrees of freedom is increased to 500, then the t value will fall to 1.96. It is similar to the z value at 0.05. So t value will approach to z value if the sample size is large. So we can use t test or z test in case of large sample size. The 10th is regression. If our dependent variable is categorical, then we must use logistic regression model. If our dependent variable is categorical and we have only one independent variable, then we will use the logistic regression. Further, if our dependent variable is categorical and there are more than one categories, such as religion, then we will use multi-nominal logit. Similarly, if our dependent variable is numerical, then we will use simple linear regression and multiple linear regression depending upon the number of independent variables. The 11th thing is correlation is not causation. Correlation only shows the movement of two variables. If two variables move together, they tend to have positive correlation, else there is negative correlation, such as price and demand is said to have a negative correlation because as price increases, demand falls, but price and supply is likely to have a positive correlation because as price increases, the suppliers will be attracted to supply more goods as their profit rises, so they tend to have a positive correlation. And there is also concept of spurious correlation. Spurious correlation means false relationship between variables, and for this detail you can follow the link I have given. That is https tylervegan.com/spurious correlation. And unlike correlation, regression is causation as it depicts cause and effect relationship. And its bonus is t-test, ANOVA, and regression. T-test, ANOVA, and regression gives same result. You can check this uh, and you can check this figure. The f value is 5.11 in case of regression. This I have done in the data. And the one-way ANOVA for food today and gender gives the same f value and same level of significance, that is 0.0277. So the results are identical. Similarly, t-test, ANOVA, and regression gives same result, and here I have taken the t-test and the regression. T-test mean value is 96126.36, while the male value is 132,849.4, and the t value is minus 2.2605. Let's check the t value in the regression below. Its t value is 2.26, and the sign of the t value does not matter, so the t value is identical. And now let's check at the level of significance or p value. It's 2.28 in the regression analysis, while it's 0.0277, which is equivalent to 0.028. So the result are same. The last is the relationship between f test and t test. F test means ANOVA and t test. The t value is the square, sorry, the f value is the square of t value. As you can see that 2.28 2.26 square is equals to 5.11, which is equal to the f value, and the level of significance is the exact same. So the t-test and ANOVA regression gives same result provided that the numerical and the categorical variable are given, where the categorical variable has only two categories such as gender, here is male and female, so the results are same. My social networks, you can follow me in Facebook page, personal Facebook, YouTube, and Instagram. And if you want to cite this content, then you can cite as below. Thank you. If you have any question, then you can ask me in the comment box below, or you can ask directly in my messenger also. Thank you.